In the silent darkness between galaxies, two invisible monsters are spiraling toward each other at half the speed of light. They have been dancing for billions of years, locked in a gravitational embrace so powerful it bends the fabric of the universe itself. No explosion lights the sky, no sound echoes through space. Yet when they finally collide, the event releases more energy in a fraction of a second than all the stars in the observable universe combined. For most of human history, this cosmic catastrophe was only a theory whispered among physicists. But now, for the first time in history, humanity has actually witnessed it. Everything changed on September 14, 2015, deep beneath the forests of Louisiana and the deserts of Washington state. Two enormous instruments known as the Laser Interferometer Gravitational-Wave Observatories suddenly detected something impossible. The detectors trembled, ever so slightly, as if space itself had shivered. The signal lasted less than a second, but in that brief moment, scientists realized they were listening to the echoes of a collision that had happened 1.3 billion years ago, two black holes smashing together in the depths of the universe. It was the first direct detection of gravitational waves, predicted a century earlier by Albert Einstein, and it confirmed something extraordinary. Black holes do not merely exist. They merge. But the discovery raised a terrifying question. What actually happens when two black holes collide? These objects are already the most extreme things known to physics. A single black hole compresses the mass of a star into a region smaller than a city. Its gravity is so intense that not even light can escape. Time slows. Space warps. Reality itself begins to break down. Now imagine two of these cosmic abysses spiraling toward each other. As they approach, they begin a violent gravitational dance called in spiral. Each orbit grows faster. Each revolution releases ripples through the universe. The closer they come, the more violently space itself shakes. To visualize the scale of this event, imagine two objects each heavier than 30 suns, collapsing into darkness, then whipping around each other hundreds of times per second. Their gravity distorts space like two bowling balls spinning across a stretched rubber sheet. Except the rubber sheet is the universe itself. The waves they create travel across billions of light years, stretching and compressing space as they pass. By the time the waves reached Earth in 2015, the distortion was smaller than the width of a single atomic nucleus. Yet it was enough for humanity to detect. And what scientists discovered next made the mystery even deeper. When those two black holes finally merged, they did not simply collide like planets or stars. Instead, something stranger happened. The two event horizons fused together, forming a new, larger black hole that violently shook itself into stability. In that final instant, an enormous burst of gravitational energy erupted outward across the cosmos. But here is the unsettling part. The energy released in that moment was equivalent to converting 3 entire suns directly into pure energy. No explosion, no light, just a silent tremor in the structure of reality. And that discovery leads to a far bigger question. If two black holes can release that much energy, what would happen if something even larger collided? To understand what truly happens when two black holes collide, we first need to imagine a place where the normal laws of reality begin to fail. A black hole is not simply a dense object. It is a region of spacetime where gravity has become so intense that it forms a boundary known as the event horizon, the point of no return. Cross that invisible line, and nothing in the universe can escape. Not matter, not radiation, not even information. But when two black holes approach each other, something remarkable begins long before they actually merge. They start to orbit. This stage is called the inspiral, and it is one of the most violent gravitational events in the universe. The two black holes circle each other faster and faster, shrinking their orbit as energy leaks away in the form of gravitational waves. These waves are not like ordinary waves in water or sound waves in air. They are ripples in spacetime itself. As they travel, they stretch space in one direction and compress it in another. Entire galaxies could be gently squeezed and expanded as the wave passes through them. Yet the distortion would still be almost impossible to notice. But near the colliding black holes, the effect is colossal. Space is twisted, pulled, and warped into shapes that defy imagination. As the orbit tightens, the speed increases dramatically. In the final seconds before the merger, the black holes are moving at nearly the speed of light. Their event horizons begin to distort under the immense gravitational stress, stretching toward each other like liquid shadows. Physicists sometimes describe this stage as a cosmic whirlpool where two gravitational wells collapse into one another. Then comes the moment known as the merger. In a fraction of a second, the two horizons fuse together, forming a single, larger black hole. But the process is far from smooth. The newborn black hole is violently unstable. It vibrates, oscillates, and reshapes itself in a stage scientists call the ringdown. Imagine striking a massive bell the size of a solar system. The vibrations that follow are not sound waves, but gravitational waves rippling through the fabric of the universe. This ringdown phase sends out the most powerful gravitational signal of the entire event. For a brief moment, the black hole radiates enormous amounts of energy as it settles into its final shape. It is here that the missing mass appears. In the famous 2015 collision, the two original black holes had masses of about 36 and 29 suns. Yet the final black hole was only 62 solar masses. 3 suns had vanished. They were not destroyed, they were converted directly into gravitational energy. But this is where the story takes an even stranger turn. Modern observatories have now detected dozens of black hole mergers across the universe. Some involve objects 50, 60, even 80 times the mass of our Sun. And every time they collide, the same violent process unfolds, and in spiral, a merger, and a ringdown. Each event sends a tremor across the cosmos that travels for billions of years before reaching Earth. Yet astronomers have begun to realize something unsettling. These collisions may not be rare. They might be happening constantly. Across the universe, black holes could be merging every few minutes, hidden in the darkness between stars and galaxies. Invisible cataclysms shaping the structure of the cosmos itself. But if that is true, it raises an even more profound mystery. Because the black holes we have detected so far are tiny compared to the giants that lurk in the centers of galaxies. And when those monsters collide, the consequences could reshape the universe itself. Far beyond the black hole mergers we have already detected lies a far more terrifying possibility. At the heart of almost every galaxy, including our own, lurks a supermassive black hole. These monsters are not merely dozens of times heavier than the Sun. They can contain the mass of millions, even billions of suns compressed into a single gravitational abyss. In the center of the Milky Way alone sits a black hole called Sagittarius A, weighing roughly 4 million times the mass of our star. And scattered across the universe are giants far larger. Some contain the mass of 10 billion suns. Now imagine two galaxies colliding, their stars passing harmlessly through each other like ghosts in the night. Eventually, the two central black holes begin to drift toward the same gravitational center. And when they find each other, the most powerful collision in the universe begins. For millions of years, these supermassive black holes would orbit each other in a slow gravitational dance. Their influence would distort entire regions of the galaxy around them, flinging stars into deep space and warping the paths of cosmic gas clouds. But as time passes, their orbit shrinks, the dance accelerates, the final stage unfolds over centuries, then decades, then hours. Two gravitational titans begin circling each other at unimaginable speeds. The energy released during this process dwarfs anything we can comprehend. When the final merger happens, the resulting gravitational wave could ripple across entire galaxy clusters. If such an event occurred close enough to Earth, our detectors would record a signal so strong it would shake the instruments themselves. But the consequences may go even further. Some simulations suggest that when two supermassive black holes merge, the final black hole can receive a gravitational kick. The violent emission of gravitational waves can propel it through space at thousands of kilometers per second. In some cases, the newborn black hole could be ejected from its own galaxy entirely, becoming a rogue monster wandering the intergalactic void. Imagine a black hole containing billions of solar masses traveling alone through the darkness between galaxies, dragging its immense gravity across the cosmic landscape. Entire star systems could be disrupted if such a titan passed nearby. Yet perhaps the most unsettling implication lies in what these collisions reveal about the universe itself. Black hole mergers are not merely destructive events. They are a fundamental mechanism shaping cosmic evolution. Galaxies grow through collisions. Black holes grow through mergers. The structure of the universe, the enormous cosmic web stretching across billions of light years, may have been sculpted by these invisible gravitational catastrophes repeating for billions of years. Each merger sends waves across spacetime, echoing through the universe like the deep heartbeat of reality itself. And humanity has only just begun to hear those echoes. Our detectors are still young. Our understanding still incomplete. Somewhere, at this very moment, two black holes may be spiraling toward each other in the darkness, preparing to unleash another silent explosion of gravitational energy. The waves from that collision could already be racing across the cosmos, crossing galaxies, passing through stars, moving quietly toward our planet. One day, those ripples will reach Earth, and our instruments will feel the universe tremble once again. Because in the grand scale of the cosmos, black holes are not rare accidents. They are the engines of transformation. Civilizations measure time in centuries. Stars measure it in billions of years. But black holes measure it in gravity.